this case it's schools, I'm guessing, right, or classrooms, or whatever it is.
Right.
The superscript represents the level, and then the subscript represents the particular path to the particular mediator, so to speak. And then you have over here, you have B2, 1, B2, 2, and B2, 3. So when you're using the complexity, you're assuming that these are the same, but in fact there may be very different relationships. If you remember, we had an example in SEM that was like the big fish, little pond.
Yeah.
These relationships can be completely different, and we regularly see that. You regularly see that context matters. In other words, what other people,
Right.
what your classmates think matters, but it matters in a way that's different. So in other words, if you took my attitude, how does my attitude affect my intentions? Well, it may be strongly positively associated with my intentions or something of that nature. Whereas other people's attitudes, what is everyone else? Maybe I'm an adversarial person. I want to go opposite other people or something like that. So if everyone else thinks it's bad, then I'm going to do the good and I'm going to go good, or vice versa. The point being is that B1 at the second level, in other words, this one right here, does not necessarily equal B1 at that student level. So this is sometimes called ecological fallacy or aggregation bias or all these different things. It's the assumption that what happens for the individual is also true at the group level, or in other words, what happens in group level processes also applies equally to individual level processes. And it's typically not true, or you at least don't want to make that assumption. And I think this would be a really interesting model if you were able to say, context matters.
So the reason that I shied away from it is that I did try it with my SEM model, so not with yes, the same thing, sorry. They're not the same. It totally blew up. So I tried to model it as a 2-level, forget a 3-level, and it just completely choked.
Right.
And especially because you have categorical data.
So I have some ideas for you. I want to keep the rest of the class because these are some
it's
challenging
complex.
ideas that integrate SEM IRT, and there's some things that are very new.
Yeah, I feel like I'm kind of
You're at the cusp.
I feel like at the limits of what my ability to do these analyses, because beyond it requires a much more sophisticated analytical solution than what my this is my culminating statistics class, so what I've had.
All right, maybe we should release other people and then continue the conversation. Are there any other questions for Rebecca?
Oh, Rebecca, I do not know. I just want to know for the fader you created on the champion model fade. So is the blue line and the red lines.
Oh, the model fit?
Yes, so I do not know how it is, how it was done here.
Yeah, so the program just does that. So I don't know if I honestly don't actually, I have to look at that a little bit more, how it creates that predicted. It's probably some sort of Bayesian.
We've done it. So the predicted is just the model-based predictions.
Okay.
So you're so they just so if you have theta, you cut it up into bins, and I can't see how many this is, but there's probably like 10 or 20 or something. I can't draw 20, so let's pretend it's 10.
Yeah.
So this is the probability. So this is our typical diagram, right? It's the probability of endorsing it versus theta, your ability level. So we have these kind of S-like curves, and what they do is take it into bins of, for example, 10.
Oh yeah, I remember we did this.
Yeah, this was like a while ago.
Yeah.
So if you did not have categorical data, this is really simple. All you do is whatever the score was observed. So if you have like if we actually knew theta, we would take theta and we'd say, okay, well theta is 0.5, and then if you could observe not the probability, but you could observe the actual response, in other words, on like a 0 to 100 scale, you could just plot, just like a regression, you plot the actual y scores as a function of theta, and then you would overlay the predicted scores, the model-based predictions. You can't do that with categorical data because we don't actually observe a probability. We only observe 0 or 1. or whatever graded scale it's on, or ordinal scale it's on. So the way that they do that instead is that they chunk it up into some number of categories. You can choose your number of categories or some optimal, depending on the software used. I don't know how they identify it here, but it looks like there's maybe 20 categories roughly. And so it says, within a narrow band, in other words, let's say this is from negative 2.1 to 2, roughly 0.1. What's the problem for all those people that had an ability between 2 and negative 2 and negative 2.1, this little window right here, how many people got it correct and how many people got it incorrect? Well, if you look at like the leftmost bottom part of it, it's probably something very small. Only one person out of all those people got it correct. And so the empirical, or the observed, what do they call it?
The observed is the red, the empirical,
Okay,
and then the blue is the predicted.
Okay.
Yeah.
So the red is the predicted. So we predict
the
that.
red is the observed. The blue is the predicted.
Red is the observed.
Yeah. Sorry.
Blue is the predicted. Okay.
Yeah.
So this, I don't have blue unfortunately, but I'll use blue and green.
Okay.
Or red and green.
Okay.
I'm sorry, I forgot already. Red is
observed.
Red is observed.
Yeah, empirical.
All right.
That's EMP.
So red is observed. So this is it's just literally the average of people within this narrow band. How many people got it correct? And then you do the same thing for the next narrow band, and you get something like this, and then so you get all those red dots. Then I guess they connect them with something like this. And then over top of that, you lay the blue, and that's the model-based predictions. That's literally, you just take the logit of the probability of getting it correct over 1 minus the probability of getting it correct is equal to A times theta minus B, or whatever the parameterization is. So you literally just multiply those out, or you can just take the probability version of it. And so you fit, in blue, you would fit the model that's something like, it looks like that. So that's the difference. Now in there, it's much closer. It's a much better fit than mine. And then they overlaid kind of 95, I'm assuming they're 95% confidence intervals.
Yeah.
And it looks something like that. And if there's one that lies outside of that, like if this one says something like that, then there would be some person misfit a little bit right here. I mean, how much that matters is give you this different type of test for that. You got it? All right.
So then you could see that most of them were pretty close fit. So
yeah, that's a great model. Yeah.
Yeah. So it told me that that's a good model. And then the other thing I did for kicks is I took the parameters, so the pretest parameters from MPlus, and then I put them into I used those as the parameters on my post-test data, and I reran these fits. Yeah. And they were still pretty tight. Not as good as this, obviously. Mm-hmm. But because normally ideally you would have a large enough sample that you could split off half your sample and then fit your model.
You have like 2,000 people?
1783.
Yeah.
So.
But they're repeated at time 1 and time 2.
Yes.
So you just
they're match pairs. Yeah.
You could use multi-group analysis or not.
Oh yeah, I didn't even think about doing
just pre-post
that.
Yeah.
Yeah, I just did that just for kicks to see what happened. Oh. But the model still fit pretty well, which just tells me that the graded response is a good model for these data.
Yeah.
So.
Also, you just like the software. I mean, you get another round of software.
It's pretty standard analyses. I think these are produced in many packages. Any other questions or comments for Rebecca? All right, let's end there. And you guys, Amanda and Rebecca, as well as Sinem, did a great job. If you guys were looking for a good example, these were awesome. I am really impressed and really interested. I wish, I think I should have changed the class format to give these. You guys think you could have given presentations of this nature or a little bit simpler, like halfway through the course? Or I'm looking to get people more involved in the course, and this could have been like I don't know if you would have been prepared or not. What do you think, Amanda?